So hi, today we are going to be starting with O-levels or igcse chemistry hard MCQs. So basically after every year, the examiner publishes a report, and I am sure you guys must be aware of the fact, and you have an examiner report, and according to that, we know that which MCQs were found most difficult by the candidates. So the general comments were, for this year, there was evidence of guessing in question number 12, 23, 24, and 38. Candidates found question 13, 16, and 18 particularly challenging. So this shows that these were the difficult questions, and in this video we are only going to be practicing the hard questions. So let's get started, and these were the comments on specific questions. These are the questions we're going to be practicing. Okay, and these special questions which were found really challenging, we're going to be spending a great deal of time understanding the core concept behind the questions. So let's get started. Question 13, 16, and 18 are going to be the main priority. Okay, so the first question is question number 1, which was found challenging. Let's get started. Okay, a student needs to measure 17.60 cm cube of hydrochloric acid. Okay, now this word is very important. What does the 17.60 tells us? It tells us that you have 4 SF in the questions. Okay, this is 1 significant figure, 2 significant figure, 3 significant figure, and 4 significant figures. Okay, of hydrochloric acid, the student has access to apparatus commonly found in a school laboratory. Which piece of equipment should be used to measure 17.60 cm cube of hydrochloric acid? Now, the value itself, 17.60, tells us about the extreme accuracy of whatever instrument we're going to be using. Okay, if it's a pipette, then this value cannot be measured by a pipette. Why not? Because pipette only measures a fixed kind of a volume. For example, if you have a 25.0 cm cube or you have a 30 cm cube exact volume, and you should have the pipette of that volume in your laboratory to measure that volume. A random volume, for example, if you have 25.8 cm cube, 80 cm cube, a pipette won't be able to measure it because it's not an exact volume for which you are commonly going to have a pipette in your laboratory. So this one right here, 17.60, is a very random number. So you don't have exact volume for it. So that's why we are not going to use pipette for it. Pipette we're going to cross. Now the key concept over here that you guys must know is that burettes measure variable volumes and pipettes measure fixed volumes. So that's the key concept, and this volume right here is a variable volume. Okay? By variable I mean that it's not a fixed, it can vary, it can change, so that's why we are not going to use a pipette for it, and we're going to use a burette for it. And a measuring cylinder does not has this much precision. Okay? It cannot measure up to 2 decimal places. Okay? It only measures up to 0.1 cm cube. That's a 1 decimal place. And a gas range. A gas range basically is used to measure gases, and what we are measuring over here is hydrochloric acid. If it was hydrogen chloride gas, then we could have used a gas range, but that's an acid. So, well, not. So, the correct answer is option A. Moving on to the next question, which says, when calcium carbonate, question number 2 was also a difficult one, a challenging one. Okay, when calcium carbonate is added to dilute hydrochloric acid, carbon dioxide gas is released. 3 sets of apparatus are shown. And now what's the question? The question is that which set of apparatus are suitable together with a stopwatch? Okay, we are given with a additional thing, that's a stopwatch, for the following this rate of reaction. Okay, rate of reaction simply means that we have to change either the decrease in the mass of the reactants or the gain in the mass of the products, and which set of apparatus is going to be more suitable. So the key concept in this question that you guys had to understand was that right now, this one right here, the first apparatus was, okay, you are simply measuring the amount of mass that is lost, okay, from your reactants. Okay, that's a good idea. If you know that initially your mass was 100 and now your mass has decreased to 50, that's a very idealistic situation. So the rate is going to be the change in mass, that's 100 minus 50 upon the time taken. For example, it took 25 seconds, so it's going to be equals to 50 upon 25. That's going to be 1 times and 2 times. So that's going to be 2 grams per second. Why grams per second? Because over here you had your measurement in grams. So you can simply measure. Whenever you have to measure rate, you have to basically look at the change in the things. How gradually something is changing, how much time it's taking for something to change. Okay, now we have the two option. Let's see it. Over here what we're measuring is the volume of the gas collected, and I guess that's also a good option because you have a tap funnel over here. You have closed the tap so nothing is going out, because you have to make sure that all the gas that is being formed, because when calcium carbonate reacts with HCl, your carbon dioxide gas forms, your calcium chloride salt forms, and your water forms. So you got to make sure that all the carbon dioxide is collected over here and nothing goes out. So that's a tap funnel is a good option because you have it closed. So that's a good option. You are going to collect the volume of the gas, and for example the gas collected is 50 cm cube and the time taken is 25 seconds. So it's going to be 1 times 2 times 2 cm cube per second. I am sure you guys see how this this kind of thing changes for rate. Over here it was grams per second, over here it's cm cube per second. Rate is basically the change. It can be anything. It can be change in the mass, it can be change in the volume. Okay, now we move on to option 3, which basically tells us again we're measuring the volume of the gas produced using a measuring cylinder. But one thing over here that candidates failed to understand was that some gas, carbon dioxide, is escaping from a thistle funnel. Remember that a thistle funnel allows the gas to be escaped. So the key concept was that thistle funnel allows carbon dioxide to escape. So that was what people found challenging. Hence, this method cannot be used to find the volume. Why? Because exactly you are not knowing that how much gas is being formed, because some gas will escape out. So only 1 and 2 can be used, so it's going to be option B. So this was the key takeaway, okay, from this question. Okay, moving on. Question number 3, it was also found difficult. Some substances may be separated using paper chromatography. Chromatography is a way of separation by which you can know the purity of a substance, the composition of a substance, and the solubility of a substance. These are 3 things which chromatography tells you. If a substance is pure, it only has 1 spot. If a substance is soluble, it will move up, and the composition of a substance, the more the spots, the more things are involved in making the substance. The diagram shows the results of running 2 mixtures in a suitable solvent. Which spot has an RF value of 0.37? Now this picture right here is not drawn to scale. Not to scale. Over here this is not to scale, so it might be difficult for you to find. But you need to understand one thing. A very core concept over here is this. Look over here. This is the core concept in the entire question. Always remember that you cannot have an RF value greater than 1. An RF value greater than 1 is impossible. An RF value greater than 1 is impossible. Ever if you get an RF value that's coming greater than 1, remember that you have used the wrong formula, because RF value can never be more than 1. Why? Because the 1 is the RF value for the solvent front. Obviously your spot is going to be below the solvent front. So just think about it like this. The top is 1. The top has an RF value of 1. So the middle is going to have an RF value of 0.5. That's the half of 1. So what is going to be, we had to find the spot with RF value of 0.37. Can you figure it out now? 0.37 is obviously going to be below than 0.5. And by using our simple scales, we know this spot is going to be 1. And if we just see the half of this thing, starting from 0, this is almost 5, and the half of 5 is going to be 2.5. This one's right here is 2.5. We have drawn a spot here. Let's make a line. So this one's 2.5. This means that this line has an RF value of 0.5. This one's an RF value of 1, okay? Because solvent has an RF value of 1. This has an RF value of 0.5, and now we have to find 0.37. So what do you guys think? Either it's gonna be B or A. Looking by, like, judging, kind of try to judge by just looking at it, I guess it's gonna be, why to guess? Just like, let's see the distances. Well, if you're good at maths and good at proportionality, you might be able to judge as well. So that's, I guess, roughly coming to be 1.2. So 1.2 divided by 5. Let's try it. 1.2 divided by 5. Oh, that's 0.24. So that means it's going to be, this one's not, that's 0.24. It's going to be option B. Okay? So option B is the correct option. Okay? You have to judge by it. You first had to eliminate these two because you don't have time to calculate for all. You just have to use your cognitive skills that, look, 0.37 means that it's going to be below the half, okay? Because half is 0.5 and more than one RF value is impossible to reach. So this was the key concept over here that you had to understand. Okay, moving on to the next part, which was question 5. Compound X is a crystalline solid at room temperature. Okay, these words are very important, which you must highlight while reading. At room temperature and pressure, an aqueous solution of X is tested as shown. Okay, now basically, this compound is a crystalline solid at room temperature, and now you have, aquified it by mixing water with it, and now you're testing it. So the test is first acidify. Okay, one thing very important. I guess the key concept or the core concept in this question was that you please guys have to learn the cations anions test for P1 O levels and P2 igcse. That's a compulsion. If you don't know the test, you're going to be caught by the examiner in such kind of situations. And secondly, I'd highly recommend the test for flames, the test for gases, the test for indicators, methyl orange, thymophthalene, and your third indicator was litmus. All these should be on your fingertips. Okay. An aqueous solution of X is tested as shown. This is the test. Acidify with dilute nitric acid, then add aqueous barium nitrate. What is this test for? This, if you guys have learned it, you should know this is a test for sulfate ion. Barium nitrate is used to test for sulfate ion, and if sulfate ion is present, you form a white precipitate of barium sulfate, BaSO4, which is insoluble. Okay. Second is add aqueous ammonia, white precipitate, soluble in excess. Okay, so what is this test for? You add aqueous ammonia and white precipitate soluble in excess. This is a confirmatory test for zinc ions, zinc 2+ ions. So, obviously we have to go with option D. And some of you guys might have confused this with aluminum test, but remember, aluminum ions are soluble in sodium hydroxide excess, but they're insoluble in excess of ammonia. So, well, this cannot be aluminum. And this was the key thing that you had to learn in this question, that you got to know the test for anion and cations. Moving on to question number 8. The diagram of an anion is shown. No, not of an anion. Anion. Oh, wow. That's such a great thing we found, anion. Okay, but that does not mean it's a negatively charged ion, because over here it's a cation. Because this ion was not part of, it was not together. It was separate. Okay, moving on. What can be deduced about the number of protons in this ion? Okay, we have to find the proton number, and we are not given with the nucleon number or anything inside the nucleus, and we're unaware of it. Okay, no worries. The key concept in this question is, let's find the number of electrons, because we know that in a neutral atom, the number of protons equal to the number of electrons. And all atoms are neutral before forming ions. Okay? Before this ion was formed, this atom must have been neutral. A neutral atom has same proton and electron number. So that's what we need to understand. And a +1 means loss of 1 electron. That means that, let's first count the electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 electrons, and we have a charge of +1, means we lost 1 electron. So before losing one electron, ठीक है, a +1 charge means we lost one. Before losing one electron, how much electrons would we have? Right now we have 10, but we lost one. So that means previously we had 11 electrons, and unfortunately we lost one and we got a charge of +1, and then we formed diene, and then we have 10 electrons. But before that we had 11. And you know that a neutral atom has same proton and electron number. So before forming this charge, this atom had 11 electrons and 11 protons. So the proton number is going to be 11 because proton number does not change. So it's going to be option C, that it has 11 protons. Okay, moving on to this question. The circuit diagram shows an experiment using a rod of copper and a rod of graphite. Okay, from theory you should know that a rod of copper is going to be an extremely good conductor. Copper is ductile, malleable, extremely good in conductivity, and you should know graphite is used as a lubricant, as an electrode, and it's used as an electrode because of its good conductivity. So it's also a very good conductor. Okay, when the switch is closed, the bulb lights up because of an electric current flows through copper and graphite. Okay, as we discussed that current is going to flow through it and this bulb is going to light up. Which particles move through these two solids? Okay, that's easy, that the particles that are going to move are obviously going to be electrons, because you should know that ions do not move in metals. I don't know why people think, but they think that positive ions move in metals. Never. Ions never move in metals. Ions only move at one place. And ions are going to be responsible for conductivity in ionic compounds only. So don't ever think that in metals ions are going to move. So copper ions, do they move? No, they don't. Which particle moves through these two solids? It's going to be electrons. And graphite does not have any kind of such thing. It is a covalent structure, so it's made up of covalent bonds. It does not have ions. So the only thing that's going to move is this, electrons. Not copper ions and not carbon ions. Oh wow, you don't even have carbon ions in graphite. It's a covalent structure, you have covalent bonds. So the key concept in this question was this, that graphite has free delocalized electrons and ions don't move in metals. So I hope you get it. Moving on to the next part. The diagram shows the covalent bonds in an organic compound. So let's just figure it out. We have two carbons, 1, 2. So it's going to be eth. And then we have how many hydrogens? We don't have any bond. That's a simple alkane. Because we have two carbons, we should have 6 hydrogen, because that's how alkanes work. So that's an ethane molecule. Okay, the total number of electrons in one molecule of this compound is X. Okay, I know why people found this thing difficult was because they didn't try to realize the total number of electrons. They only counted the last shell electrons. But over here, the question is very clear about that it needs the total number of electrons. So first, let's figure out the total number of electrons. And we have to see that the first shell has 2 electrons. Okay? And many people must have not seen the first shell. So for the first shell, we have 1, 2. In a carbon, carbon is in group 6. Okay? Not group 6, sorry. Is in group 4, and that means that it has a total number of 6 electrons because the last shell is going to have 4 and the invert shell is going to have 2. So you have 1, 2, 3, 4, 5, 6 in total. And how many carbons you have? You have 2 carbons. So that's going to be 2 times 6, okay, because one carbon has 6 electrons. In a covalent compound, no electrons are being lost, no electrons are being gained. Simple thing is, the total number of electrons are going to remain constant. And for hydrogen, it's simple. Hydrogen is in period 1 and group 1. So that means it's going to have one shell with 1 electron. That means that how many hydrogens we have? We have 1, 2, 3, 4, 5, 6. That means simply 1 times 6. So that's going to be making it 12 plus 6, and that should be 18. So the total number of electrons should be 18. Now let's look at the next part, which says the total number of electrons in the bonds of one molecule of this compound is Y. Now we are talking about the total number of electrons involved in the bonds. Okay? So let's draw the bonds to find over here. The bonds are going to be simple. We all have one covalent bond, a single covalent bond. Okay? So over here, one covalent bond, all the lines represent a one covalent bond. So we're gonna draw it. So we are done with all our bonds. Now let's count the electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. If you found it difficult, just count the bonds and multiply it with 2, because each bond has 2 electrons. So 1, 2, 3, 4, 5, 6, 7. 7 times 2 equals to 14. So the electrons involved in bonds were 14. According to that, our option Y is going to be 14, and that makes it D. Okay, now we're moving to extremely difficult questions that were found extremely challenging. I've highlighted with this blue kind of thing. So now this question is, which contains the greatest mass of oxygen? Now the key concept over here is that you have to understand the mass of 1 mole of a substance. So you have to understand that 1 mole of AlNO3 aluminum nitrate 3 contains 16 times 9 144 grams of oxygen. How that's? Because over here you have 3 oxygens, and over here you had a 3. So 3 times 3 makes it 9. So in total you have 9 oxygens, and the mass of one oxygen is 16. So 16 times 9 144 is going to be the mass of 1 mole of the oxygen present in 1 mole of aluminum nitrate. But over here you had 0.2 moles of aluminum nitrate. So you have to understand that if 1 mole equals to if 1 mole equals to 144 grams, so 0.2 moles equals to x grams. So you just had to figure out the value of x from here, and this was the key concept. Another thing that you have to understand is the mass of 1 mole of any substance. Why isn't this getting? I don't know why, but you have to understand that 1 mole mass of any substance equals to the MR of that mass. So 1 mole mass of this CH4 or methane is going to be 16 grams, because that's the MR of that thing. So similarly, the 1 mole mass of aluminum nitrate is going to be the total mass of the MR of this thing. So 1 mole in 1 mole, how many oxygen are you going to have? The mass of oxygen in that substance. So that was easy. From over here, you had to find the value of x by simply multiplying 0.2 with 144. So that should be 0.2 times 144. It's going to make it 28.8 grams of oxygen. Okay, next is 0.3 mole of potassium sulfate. In 1 mole, how many oxygen do you have? You have 4 oxygens. So in 1 mole you have 4 oxygens, meaning 4 times 16. So how many are you going to have in 0.3 moles? 0.3, you're going to have x. Just find the value of x by multiplying 16 times 4 with 0.3, and that's going to be 19.2. So over here the value of x comes out to be 19.2. The next thing is that 0.4 mole of sodium nitrate. In 1 mole of sodium nitrate you have 3 oxygens. So simple working, that in 1 mole you have 3 oxygens. That's going to be 3 times 16. So how many oxygens are going to have in 0.4 moles? That's going to be x. So it's going to be 16 times 3 times 0.4. It's going to make it 19.2. It's also 19.2. And 0.5 mole of magnesium carbonate. So 1 mole of magnesium carbonate has 3 oxygens. So again, a simple working, that 1 mole has 3 times 16. So how many is going to be in 0.5 moles? That's going to be x. Let's find the value of x, which is going to be 0.5 times, first let's go simple, that it's going to be 3 times 16 times 0.5. That's going to be 24. So we have 24 grams over here. So this was all the masses of oxygen. So which contains the greatest mass of oxygen? Undoubtedly, it's going to be option A. I hope this was what you guys understood. The key concept over here was simple, that you had to understand that 1 mole of mass of any substance equals to the mR of that substance, okay? The molecular mass. So 1 mole of this would contain equal amount of oxygen as in the molecular formula, okay? So moving on to the next question, which was this, that was found challenging. These were the extreme questions that were found very, very challenging. So let's understand this. What sample contains the most atoms? Now what we're talking about is atoms. We have to look at atoms. 0.5 mole of water, 1 mole of carbon dioxide, 1 mole of methane, and 2 moles of hydrogen chloride. So now you have to look at one thing. That's the formula. Water is H2O. Okay? Water is H2O. Carbon dioxide is CO2. And 1 mole of methane is going to be CH4. And 2 mole of hydrogen chloride, it's going to be HCl. So now you should understand that in how many atoms do we have over here? We have 3 atoms in 1 molecule of water, 2 for hydrogen and 1 for oxygen. We have 3 atoms in 1 molecule of carbon dioxide, 2 for oxygen, 1 for carbon, so total 3 atoms. We have 5 atoms in 1 molecule of methane, and we have again 2 atoms in 1 molecule of hydrogen chloride, but over here we have 2 moles. So 2 times 2, we're going to have 4. That's easy. Simply, it's going to be option C. We don't even have to think about it, because look, we have 5 atoms over here, okay? For 1 mole. Over here, we have for 1 mole 3 atoms, so definitely not this. For 0.5 mole, 3 atoms, no. So it's going to be for 1 mole, 5 atoms. These are going to be the greatest number of atoms. So that was the key concept. You had to understand the number of atoms. And you also had to understand one thing. If they asked for the total number of atoms, ठीक है? अभी तो उन्होंने most number पूछा ना. If they would have asked for the total number in terms of numbers, ठीक है? Not in terms of this, they would have written number. Then you had to look at one thing, that 1 mole of water contains 6.02 into 10 raised to power 23 oxygen atoms, 6.02 into 10 raised to power 23 times 2 hydrogen atoms. And this might be confusing, but that's how it works, because you have H2, so you multiply the Avogadro's number with 2 to get for hydrogen and with 1 to get for oxygen, and if you would add both, you're going to get the total number of atoms in 1 mole of water. So it's going to be option C. Why? Because it's going to be 5 times 6.02 into 10 raised to power 23, because total atoms are 5. Over here it's going to be 4 times 6.02 into 10 raised to power 23. Why? Because over here you have 2 moles, and 2 are going to be multiplied with the number of atoms that are 2, which are going to be then multiplied with the Avogadro's constant. I know this question was difficult, but that was the key concept. You had to understand the number of atoms, and you had to understand that how you calculate the number of atoms from the molecular formula. Okay? So moving on, this question. Aqueous copper 2 sulfate is electrolyzed using copper electrodes. The current is constant. Okay, now important concepts. You're using reactive electrodes. Second important concept, that your current is constant and the anode is weighed at regular time intervals. The time intervals are also regular. Which graph is obtained when the mass of the anode is plotted against time? Okay. So the important concept over here to understand is that our anode must have initially some mass. Okay? Initially uska kuch mass hoega na. Now the thing you had to understand is that either the anode gains mass or the anode loses mass. So you should know that what's going to happen at anode is your copper is going to oxidize. This ox stands for oxidation, and oxidation means loss of electrons. So your copper is going to lose 2 electrons. So that's going to be Cu2 plus 2 electrons. And after losing 2 electrons, what's going to happen is that your anode is basically losing copper. So that means that the mass of the anode definitely has to decrease. Now this is not a decrease graph, and this is not a decrease graph. that's a constant indication of increase. The two decrease graph we have over here is right over here there's a decrease, and right over here is a decrease. Now comes in the second important part, which states that the current is constant and weighed at regular time intervals. Constant current means that there should be a constant decrease. This one indicates a constant decrease, and this one indicates a non-constant decrease. Okay, that's not constant. That means a greater decrease at the beginning and less decrease at the end. That's not correct because we have a constant current. That means it's going to be constantly decreasing, which makes it option C. And the key concept in this question was that you had to understand that anode has some initial mass, which is over here, and after that the mass of the anode decreases as copper electrodes are reactive. You had to understand the concept of reactive electrodes, and since the current is constant, so there's going to be a constant decrease in the mass of the anode, and this C graph shows a constant decrease. The line is straight and it's linearly going down. So I guess this one's clear. Moving on to the next question, which was found difficult, was question number 23. Let's read it. Which row correctly describes the solubilities of both ammonium sulfate and sodium carbonate in water? I guess that's the easiest question in the entire file. I don't know why people found it difficult, but you simply had to know the solubility rules. I guess cramming based questions are the easiest, in which you simply have to learn cation anion test, you have to learn the test for gases, the solubility rules, and it just makes life a lot easier. So all sodium salts and all ammonium salts, all potassium salts, all group 1 salts, they're all soluble. So ammonium sulfate is going to be definitely soluble, and sodium carbonate is going to be definitely soluble. So simple concepts, both are going to be soluble. Okay, lead 2 chloride is an insoluble salt. You should know this by yourself as well, that lead chloride and silver chloride are insoluble because lead and silver halides are insoluble. Which two reagents are used to prepare a pure sample of lead 2 chloride? Okay, now the important concept over here is that I guess most people struggle with and they don't understand that whenever you have to make an insoluble salt, you have to take 2 soluble salts to make an insoluble salts. Okay, always remember, I don't know how important this stuff is, that I don't know how to highlight its importance in terms of words, but I guess in chemistry that's extremely important, that whenever you have to make an insoluble salt, you're always going to take 2 soluble salts. So we have to take 1 soluble salt for lead and 1 soluble salt for chloride. So let's figure it out. Lead 2 carbonate, is that insoluble or soluble? Because these are the reagents, insoluble, because all carbonates are insoluble except group 1 and ammonium. So this one's a definitely cross. And hydrochloric acid, that's soluble. Okay, lead metal and dilute hydrochloric acid. What do you guys think? Lead metal and hydrochloric acid. Let me tell you an interesting thing about this reaction. Okay, you have this lead metal right over here, which is Pb, and you have this hydrochloric acid right here, which is HCl. What is this going to form? This is going to form lead chloride. So a layer of lead chloride forms around your lead metal. Okay, so this is PbCl2. And now what happens is that your lead cannot further react. Lead is above hydrogen in the reactivity series. You should know it. So lead can displace hydrogen. But what basically happens in this reaction is unable to proceed because of this layer of lead chloride that forms over lead, covers it from further reacting. Hence this reaction does not proceed, because you should know that lead chloride is insoluble, impermeable. So hydrogen cannot further get to react with lead. So that's how this reaction proceeds. Hence we are not going to do this thing. Okay, moving on. Aqueous lead 2 nitrate, all nitrates are soluble according to the solubility rules, and hydrochloric acid, acids are already soluble, so it's going to be definitely option C. And lead 2 oxide, oxides are insoluble, and oxides are insoluble except for group 1 and no, nothing else. Group 1 oxides are soluble. Majority of the rest are insoluble except a few exceptions, and hydrochloric acid soluble. So what you had to do, you had to have 2 soluble salts to make an insoluble. This was the key concept in this question. Okay, the next question is this one right here. Ethanoic acid is reacted with propanol. Okay, simple. We have an acid that's basically reacting with an alcohol. Acid plus alcohol, what do you guys think? that makes? You have acid, you have alcohol, you just add a bit of sulfuric acid to it that acts as a catalyst, and then you have an ester. So that's the reaction for ester. And what's going to be the ester? Well, you have to look that the first part of the ester comes from the alcohol. So it's going to be propyl, because the alcohol is propanol, and it's ethanoic acid, so it's going to be propyl ethanoate. That's going to be the name of your ester. What is the name and structure of the ester produced? We just figured it out. It was propyl ethanoate, not ethyl propanoate. If that was the case, you would have ethanoic, you would have ethanol and propanoic acid. Okay? So propyl ethanoate, and that's going to be for ethanol and propanoic acid. So that's across. That was the first thing that you had to understand in this question, that the first part of the ester comes from the alcohol and the second part of the ester comes from an acid. This was the key concept. Now the structure, I guess it should be easy. Let's see. You just have to have propanol, that means 3 alcohols. You have to break down your ester. Okay? That's also an important thing. I guess you guys should learn how do you break your esters. You break your esters from exactly this carbon-oxygen bond. Over here you break your ester. Okay? Now my ester is broken, and this part of my ester comes from this double bond part comes from my acid, and this part comes from my alcohol. So I should have 3 carbons in the alcohol part. Why? Because I have propanol. So unfortunately I only have 2 over here, and I should have 2 carbons in my acid part because that's ethanoic acid, and I have 3 over here. So that's the structure for ethyl propanoate. Trying to bluff us and confuse us. Okay, let's move to option C. That should be correct. Okay, that's correct. First, what we're going to do, step 1, break your ester. Look at the acid part. The acid part has 2, that means that's ethanoic acid, ethanoate, and the alcohol part has 3, that means that's going to be propanol, and we have propyl. So it's going to be option C. Moving on, this was the key concept in this question. Okay, the diagram, that's going to be the last question, the last difficult question of this file. The diagram shows the repeat unit of a polymer. So this is the polymer right here, which correctly identifies the polymer and type of polymerization involved in making this type of polymer. Okay, look at this polymer, and you guys have done the theory part, so try to identify what's happening over here. Can you see any kind of functional groups or anything? No. What do you guys think is happening over here? I guess what you're doing is breaking a double bond from the center, and after that you have extended 2 side bonds. I guess that's the thing what's happening. So that's going to be an addition polymer. You can see no kind of reactive groups at the end or functional groups at the end. In condensation polymer, always remember that you are going to have your functional groups at the end, which are basically going to react. You have an alcohol group or a COOH group or an OH group that's going to be at the end. And condensation polymerization is basically, when you see it at the first glance, you identify that this one's not a condensation one. Okay? This is an addition polymerization undoubtedly, because in addition you break a double bond from the center and extend it outwards. So we are pretty sure right here that it's not going to be a condensation one. So no condensation, addition. Option A or B is option A or C is the correct one. Now let's identify where the double bond was present. Now over here comes the concept of addition polymerization, that if you try to combine this thing, this is C2H5. Okay? C2H5. I hope there's no problem. You have 2 hydrogens and you have 3 hydrogens. You combine them, they become 5 hydrogens. And you have C2. So that's going to be C2. You have 2 carbons and H5. So you can just simply, I guess that's what you guys should know, and you guys should have done it as well. You can simply remove this part. Okay? Remove this part. You don't see it anymore. And instead of this part, you can simply write C2H5. Okay? That's simply allowed. You can do this. So that's basically your monomer. Not your monomer. Until these bonds here, you just remove these and you add a double bond over here. Remember that in addition polymerization, you have the double bond in the center, not the exact center of the molecule. What I mean to say is, where the double bond is broken, from those two carbons you extend out the bonds. Okay? From where the double bond is broken, from there you extend out these continuation bonds. So the double bond has to be broken from the center, because from there you're extending two bonds. Over here, the double bond cannot be over here. Why cannot the double bond be over here? If it was over here, if this bond would have broken, then one extension bond over here and one extension bond over here. Okay? So that's the concept you need to understand. From where you break, from there you add two bonds. So this is simply not possible. And over here, this is also incorrect because you had to add a 2 over here, CH2. So the correct one is gonna be option A. So we are done with all the difficult question of this year, which was, I guess, 507011 October November 2020, and I highly suggest the IGCSE people to do the O-levels papers because they are difficult, because you're given 1 hour for an O-level paper, and for an IGCSE paper you're given 45 minutes for the same 40 marks in both papers. So I guess you should try them. And the concept over here was that breaking a double bond forms addition polymer, and double bond always present in the center carbons in the monomers. Okay? From where you break the bond, from there you extend the bond as well. So that was it for today. I hope you liked the video, and thanks for watching. See you in the next video. Bye.